Okay, so the next example is kind of nice because it's giving us the conditions of a graph and it wants us to graph it. And so it really helps to know what's going on and what the notation means. And so this kind of tests that you know that or not. So g of 3 equals -1. And so you should know what that is talking about. And so basically this is just saying we have a point, right? When x is 3, our y value is -1. So there's different ways that we could graph this. So there might be different results. You just have to make sure that all the conditions hold. So I'm just going to put a point at 3, -1. The next piece says that the limit as x is going to 3 of g of x is 4. So that tells me that as I'm coming into x equals 3, let me just put it here. Oh, I already know that I have a point down here. That means that over here, I'd have to have an up above x equals 3. That has to equal 4. I have to have an open circle. I'm not quite sure right now, is the graph going to kind of look like this? Or maybe it's coming downward, it's decreasing. I'm not sure until I look at other information. But for now, maybe leaving it like that, and I can go back and manipulate it if needed. So C says the limit as x is approaching -2. So I'm going to look at where x is -2. This plus symbol is that superscript is saying to the right. So coming in on the right, it says my y value of g of x is going to be 1. Okay. So coming in on the right, I have to hit 1. So I could be coming down like this, or I can be coming up like this. But either way, I'm hitting 1 or getting closer and closer to 1. For now, I'll put an open circle. It tells me that g is increasing from -2 is less than x is less than 3. So that means that it's going up from left to right between the x values of -2 and 3. Okay, so if it has to go up from left to right, then I know that over here, this could look like this. This is strictly increasing. It didn't say that it had to be decreasing after x equals 3. If we want to, we can maybe have a horizontal line, we can have it decreasing, but whatever you want, maybe just going downwards. And then it tells me for part E that the limit as x is approaching -2 on the left has to be a bigger number. So that y value has to be bigger than the number as x approaches -2 on the right. We knew from up here that the limit as x is from part C, that the limit as x approaches -2 from the right was going to +1. And we know that that number has to be smaller than the one on the left. So if we're coming into x equals -2 on the left, it has to be above 1. So it doesn't matter where you put it. So maybe right here. Okay. And I don't know why it's not drawing anymore. Okay. So bigger here. It could be increasing, it could be decreasing to that point. It doesn't give me the direction, so maybe just coming down. So this y value as x approaches -2 on the left is a bigger number, y value, than when we're coming in on the right and we hit 1. Okay, so here's an example of a graph that satisfies all 5 of those conditions. Okay, so look at maybe number 5, and I'm going to pause the recording. Why don't you guys try it and see what you get. So either true or false. If the statement is true, you should know why it's true, and if the statement's false, you should be able to tell me why it's false. So let me give you like 3 minutes just to kind of go over that and see if you can do it, and then we'll talk about it. Okay, so this first one, the limit as x is approaching -1 on the right hand side of f of x equals 1. You guys think that's true or false? You can type in the chat. You can just say it.
True.
Okay, so true. So x is approaching -1 on the right. So here's -1 on the, and then on the right, it's saying we're coming up to 1. Yep, so that's great. That's true. What about x is approaching 2 of f of x equals 2? True or false? If we're approaching 2,
False.
False.
the left and the right. So there is an open circle there, but is that y value getting closer and closer to 2, even though that's our open circle? So for instance, like if I chose 1.7, right, that's the left of 2 and it's close to 2. Notice right here, my y value is 2. If I chose 1.9 and I go up here, my y value is still 2. If I choose 1.999, I'm still getting closer to 2. Even though it's an open circle there at exactly x equals 2, my y value is still getting closer and closer to 2. So this is actually a true statement. So this is actually true. You guys okay with that? Even though that's an open circle, it's never getting to 2. It's getting closer and closer to 2 on both sides. Okay, so C says the limit as x is approaching 1 on the left of the f of x is 1. True or false? So if we're looking at coming into 1 on the left, is your y value, you're getting closer and closer to 1? I'm not actually getting to 1, but on the left-hand side, I am getting closer and closer to 1, like 0.9, 0.999, 0.9999. So this was still true. And then D says the limit as x is approaching 1 on the right. So the right-hand side, I have to use this horizontal piece up here. As I'm coming into 1 on the right, what is my y value? That one actually gets to that y value, and that y value it says is going to be 2. So this is actually true. The limit as x approaches 1, though, doesn't exist. And that is also true because the left-hand side equals 1, while the right-hand side as x approaches 1 equals 2. That y values have to be the same y value they're approaching on left and right for the limit to exist.
So if they have a conflict in points, then that don't exist.
Yeah, exactly. The limit as x is approaching 0 on the left of f of x equals the limit as x is approaching 0 on the right of f of x. Are you getting the same y value as you're coming into x equals 0 on both sides? So here's x equals 0. Am I getting the same y value in each case?
Yeah.
So we're getting the same y value, so those limits do equal. What is that limit? I just asked us true or false, but the limit we could tell is what?
0.
Right, so limit would be 0. That y value there is 0. And now look at the limit as x approaches 2 of does not exist. So the limit as x is approaching 2 does not exist.
Would that be false or?
Right, that's false. It actually
Because it's
does
not
exist.
approaching.
What is the y value that it's approaching? Even though
Um,
it's not existing there, the y value is
2.
Yeah. So this is false.
So if it's not approaching from the other side and it's on an open circle, then it doesn't exist as well.
Right. Right. So if it had just this piece of the graph right here was maybe not even on there and, it just stopped, there was no X values greater than 2, then the limit wouldn't exist. Or if there had been some jump up here where it was like this, and this piece wasn't here, then the left and the right would be coming to different numbers, so it wouldn't exist. But because they're coming to the same Y value as X is approaching 2, even though it's not there, it exists and it is 2. So only the last one was the false. Okay. So hopefully you got that right. And if you didn't, or if you were struggling, you figured out where your reasoning was wrong and how to do it.